Alright, so work on this case has begun. I've got a bit of time-lapse footage of this thing being built, but I figured I'd just show what it looks like right now. I don't have any kind of a lid done for this, but so far it's turned out okay. I printed this with ABS plastic, so as you expect, it warped quite a bit. This is printed in two pieces. As you can see, they're just kind of glued together in the center here. And this didn't actually come out very strong either, so I went ahead and took some acetone and just went over it with a brush. Just brushed acetone over it. I also glued the little rubber feet that we pulled off the bottom of these batteries onto the bottom of the case here. So it actually does sit pretty nicely, especially with the actual batteries in it, because right now it kind of wobbles a little bit. Anyhow, I've taken my XT60 connector off this battery pack because I'm going to have to redo it, because my idea will be to have this in here about like that. You see now it actually sits pretty level. It doesn't slide too easy. So my idea is to have the negative battery wire actually come around from this side and just snake along the batteries here, and just have a really short positive jumper wire, and I'll have an XT60 connector hooked straight onto the batteries so I can use the power inverter, which I already have this connector on it. The power inverter will sit like on this end, something like that. It might be Velcro to it or something. This power inverter is actually a little bit bigger than the case, but that's okay. And then I'm also going to have probably another XT60 connector that's wired into some kind of protective circuit in here that I plan on building out of like a little Arduino AT-Tiny85 or something like that. And the other thing that I was thinking about doing was taking some LED strip and just sticking it all the way around the side of this thing, and actually make a pretty cool little lantern thing that actually should be reasonably bright. Anyhow, I'm also going to have the balance connector just kind of glued on the side, sticking up on the top over here, and this should actually be pretty easy to extend. I just have to make this one wire a little bit longer here, and it should be able to reach at least to the point where I can get this to stick up from the top. So that should be pretty simple. So I've still got to work on the circuit protection, but I should have plenty of room to stick it over here. Have a 12 volt output for maybe I'll get like cigarette lighter plugs and put another XT60 on the end of that and be able to plug that into it, and just have a general purpose 12 volt output. But the next thing I'm going to do, I'm going to go ahead and first off I'll extend this wire over to this side so it'll actually reach, and then I'll show you how to actually solder the XT60 connectors onto the battery and the XT60 connectors to the wire. So let's go ahead and do that. Alright, so first off I'll go ahead and just take this battery pack out of here. And we'll desolder this very last wire here on the balance connector. Okay, so there's that. And I'll go ahead and find a similar wire to this and get that put in here, and I'll get a piece of heat shrink tubing to put over that. Alright, so I found another piece of wire here. This is this matches the same type of wire here. This is they're both silicone type wire. I think this might be a bit thinner. I think this is 22 gauge and this stuff's like 24 or something like that. So anyhow, these will be close enough. I don't have a black piece of silicone wire, unfortunately. I got this blue piece, so it will work at least. So go ahead and strip this wire off. Alright, so there is our extended piece of wire onto here. I don't need that much wire on it, but that should actually be enough. Just like that, and I'll cut that off there. I might end up putting the connector something like that, just near this end of the battery. So that should work pretty well. Make sure there's enough slack in this. And I'll get a piece of heat shrink tubing and put over that before I solder it onto the main battery here. Alright, so that's that. Should be playing long enough now, at least just to go to here and have a hole in the lid for that. So, anyhow, let's go ahead and grab some thicker wire and an XT60 connector, and we will get that put on here. Alright, so here is a pair of XT60 connectors. It'll be this end that you want to put onto the battery and this end that you want to put onto whatever you're plugging into the battery. But when you're soldering these things, you want to have them put together. And the reason why you want to do that is in case one of these pins gets, well, it probably will melt the plastic in here a little bit. You don't want them getting loose and starting to wiggle around, and this other connector will help hold the pins on this connector in place. So just want to leave them put together like that. And the first thing that we'll do with this is just grab the helping hands, put our connector in here, and we will want to fill up the, get a closer shot of this. I just want to fill this little brass or whatever this is. It might actually be gold plated. I'm not sure, but you want to fill that up with solder. Alright, so that's good enough. Sorry about that, I don't think the camera focused on that very well, but you'll want to come in here and touch your soldering iron to the underside of this little contact here, and then just fill this up with solder. And I'll try to keep my hands out of the way, but that's a little bit difficult to do. Alright, so that should be good enough. Now we will figure out how long wire we need for this battery. And I've got that really thick 10 gauge stuff that's kind of stiff. So I don't really want this to be too long or too short, because it's kind of a pain to work with. So let me zoom out a bit. And this is the wire that I have to do this with. It is 10 gauge, but it's got a limited number of strands in it, so it's not all that flexible. And we'll just kind of come in here and we'll guesstimate how long I need this to be. So I'm going to come around here, and this is going to get soldered onto this side of the battery, and it'll come back in front. And we'll just need a couple inches on the end of this for the connector itself to come in here and actually go up through the plastic. And like I said, this stuff's really stiff, so it may not be all that easy to work with inside this case. So let's make it the scientific guessing here. I'm going to make it something like this long. It should be enough, and the red wire is actually going to be pretty short because all it's got to do is come from this side of the battery and go up to the connector. So if I make it just go from here and go, well, I only need it something like that long in order to get the connector. We'll go a little bit longer than that. Alright, so I got this little piece of wire. I'll get soldered onto here. Should be more than long enough. At least just to reach our connector. That's all we need it to do. So the next thing we need to do in soldering the XT60s is to tin the ends of the wires. So we'll go ahead and strip the ends of this off first. And you don't need very much of it stripped off to solder to the XT60. Something like that should actually be plenty. So there we go. You can see it's a relatively low strand count wire. So anyhow, that does make it pretty stiff, like I said. So push this out of the way again. Alright, so we'll go ahead and tin the end of this wire here. And hopefully the camera will focus on that. This iron may need to be just a hair hotter in order to get this to actually transfer the heat through all the way. That might work. Alright, so that should be enough. Take this off of here and do the negative wire. And I'm just going to bump the temp of my iron up a little bit here. So iron temperature is at 800 degrees, and this is a Heiko, what is it, FX888D. For anyone that's curious about that. And this is some really, really thin lead-free solder, so it's a little bit of a pain in the butt to work with, but it actually does a pretty good job for how much everybody complains about the lead-free stuff. So there's the negative wire. I have no idea how well that's focused. Camera doesn't know whether to focus on the table or the thing above it, but anyway, there's that wire. And we'll take our XT60 connector, which you'll notice is actually labeled positive, and on the other side there's little negative symbols on that. So okay, as for soldering on this 10 gauge wire onto your XT60 connector, pretty simple since we already have the wire tinned. You just come in here with your soldering iron, which is currently set at 850 degrees Fahrenheit, which is pretty hot. And that's just because I'm using this relatively thick 10 gauge wire. This is one of those situations where it is actually a little bit better to use a unregulated, like 60 watt iron, And you'll have to put a bit of force onto this. The solder will eventually melt on the wire and in the connector. Just like that. So anyhow, hopefully that was actually in focus. I've got both the wires soldered onto here now. Come on. There we go. So, yeah, it's still pretty hot. That will be a really strong connection. Supposedly these XT60 connectors are capable of handling 60 amps. I'm not sure what voltage they're really rated for, but of course we're only using it at 12 volts, so that doesn't really matter. So really the last step of this is to get some heat shrink on it, and then also solder it to the battery, of course. So let me find a little bit of heat shrink tubing for this, and I'll be back. Alright, so we'll go ahead and take our little pieces of heat shrink here. I kind of hope that they fit. Now the insulation on these wires will get a little bit melted, so you may want to clip that off a little bit with some side cutters, and that'll just help this probably slightly too small heat shrink tubing fit under here. Alright, so that should at least be good enough there. Go ahead and take a lighter. And the last thing that I'll do here is just pull this, and if your connections are solid, you should be able to yank it off by the wires. But you just take that connector off. These actually don't fit on there too tightly. Some people like to use those Anderson connectors or whatever they are, but I like the XT60s because they're just cheap and pretty easily available. So anyhow, that looks pretty good. We'll go ahead and get this thing soldered onto the battery, and I'll be back with that. And that process should be pretty much the same as this. I'll tin the battery and I'll tin the wire, and we'll get this stuck on there. Alright, so our wires have been soldered into place here, and I've kind of cut these little foam things off of here, so I should actually be able to hold that wire in right there and take advantage of the fact that these batteries are cylinders and actually use that space between them for something useful. So anyhow, that's that part of this. And this may go like over here somewhere. I don't know. It's pretty stiff, thick wire, so it'll be a little bit difficult to work with, of course. But I'll find some place to put it. On the case, that is. So actually, let's go ahead and try to shove this in here, because the case itself may be able to hold that piece of wire in there. Oh yeah, that seems to work. And this will go over here. And this can actually go like to the outside edge or something. Like right here, and the battery connector. And the battery connector is actually going to sit probably about like that, and it'll be glued to the top. Because this piece needs to be pushed down over the top of that, so this can't actually be recessed in there, neither can this. These will actually both sit up a little ways. And I still have enough room to stick a circuit in here of some kind, it looks like. So that should actually work fairly well. So pretty sure that's going to be fine the way that is. Next thing, I'm going to go ahead and grab some LED strip and just run it around the outside of this and see what we can get with that. So with this, I'm kind of thinking I'll take, since this is the really cheap, I think they're like 3850 size LEDs in here. They don't pull a whole lot of power. They're pretty bright, but they don't pull a lot of power. So I'm thinking I'll probably run one strip along the bottom and then one strip along the top and wire them together in parallel. Go ahead and take this battery bank out of here. Just so it's a little bit easier to work with, but I think so far this is turning out fairly nicely. And we'll go ahead and stick this down to it and see what happens. And I'm just going to go all the way around this whole thing. And we'll start on the top. Alright, so that doesn't look too bad actually. Just with the LED strip all the way around it. Have to see what this looks like with some power stuck on it then. That will actually make a pretty little bright little box actually with the second strip stuck on there. So anyhow, I'll probably solder a bit of wire onto the end of this strip here and connect them, either that or might be better off just soldering wires down from this one or doing something like that in order to get power off them. I'll go ahead and stick the second ring of LEDs around this and I'll wire them together. Alright, so I got the second piece stuck on there and wired in. I just hooked the ends together there. Go ahead and set this battery pack in here just to set it in here the way it's supposed to be, make it look somewhat organized. And I'll hook up the LED strip just to see. Like I said, I will get some kind of protective circuit built up for this thing so it doesn't over drain the batteries. That's actually not half bad there. Not real sure how much current these little LED strips will draw, but I have a feeling that that would actually last for quite a while. So anyhow, the next step to building this case will be actually designing a lid and putting it over this thing. So anyhow, I guess we'll have some time lapse of a lid being printed off for this thing, and then I'll actually assemble it here. And well, I've got to design that lid first, and so this may be a little while before I can get this completely put together. But I'll go ahead and start working on the lid and getting all that done. But the little proof of concept here actually works fairly well for this little case, and I like it so far. So. Alright, so the pieces of the lid have been printed and slightly modified. But anyhow, I just wanted to show the difference in between the part that's been brushed with acetone and the part that hasn't. These lid pieces actually came out reasonably strong. They weren't all cracked up like the outside pieces were. Anyhow, that's the difference between those two. And right now, this doesn't really sit very well. But I think I can get that fixed, hopefully. But anyhow, I did have to do a little bit of sanding on these, or particularly on this side, just to get it to not... Like right now, it actually sits flat. If I push these in, it starts to wobble like that. I'm not real sure what the deal is with that, but if you notice, when you push these pieces in here just individually, they don't actually fit in there right, and they... Hopefully I can get this back out. There we go. But they kind of sit in here crooked, so I think that might have something to do with it. Something to do with them twisting, but anyhow, these LED strips didn't really stick on here very well, so these are going to get peeled off and they'll be moved to plan B, which will be just gluing them on here. Some parts of it they stuck okay, but anyway, I'm going to go ahead and show you the process for coating this stuff with acetone, in case you've never seen that before. I'm not sure if this actually works with PLA, coating it in acetone, but with ABS plastic, that is a nice advantage of it, is that you can get it to look really nice, shined up. You see, it's still not smooth, and these would have been the sides that were printed on the blue painter's tape, which I'm using on my printer in order to get them to stick. But they don't come out perfectly smooth, but they do look a little bit better, and they actually are a bit stronger if you use acetone on them. So anyhow, I'll go ahead and move the camera up on the desk here, and we'll take a look at this. Alright, so what I usually do, just take a paintbrush, dip it into the acetone, and just kind of run it across the plastic like that. Make sure you keep clean acetone on your brush, otherwise it's going to start leaving like a white residue all over this part. It's not going to look nearly as good. But you'll notice when you brush it on, it'll look like it's wet. It'll just continue to look like it's wet after that is, because it's shiny, and hopefully the camera picks it up at least as good as my eyes do. And I don't really have very good lighting conditions here, unfortunately, but you know, this is pretty simple. It's basically just like painting, but you're painting with chemicals. So anyhow, there's the whole thing covered in acetone, nice and shiny now and a little bit stronger. It does dry pretty quick, so you don't really have to worry about that too much. Anyhow, if you're wondering what all these holes are for here, one of these will be the main power connector, the XT60 connector. That's hooked straight onto the batteries that the inverter will get hooked up to, and as well as to charge it. This hole is for the balance connector. This other hole is for an XT60 connector, which will be protected. These two holes are for indicator LEDs, and these two holes are for switches. So anyhow, that's that plan. And this little slot that's cut in this side, that's for the wires that are coming off of those LED strip. So that'll be the next step. I'll have to glue these pieces together, and that's about as simple and as boring as it sounds. It's just taking a bit of super glue and letting these sit overnight with the glue on them. So I'll get that done. I'll reattach the LED strip, and I'll be back probably tomorrow. Alright guys, I've gotten this glued together, and now you'll notice there's like this white film that has built up around where the glue's at. I believe that's because when the solvents and the glue evaporate, they end up condensing back onto the plastic and melt the plastic again, and you end up with that film. So the easy way to fix that is take a bit more acetone and put it over the patches of that white film looking stuff, and try not to go over the glue too much because it will probably break the glue eventually or weaken it. But see, like even on the sides here. Alright, so I've got this all cleaned up with acetone, looking pretty nice. Now that's the final lid. Go ahead and see if the thing actually fits on there now. Alright, so this is pretty much the finished product here. Last thing that I'll have to do is actually mount another connector in here, as well as the LEDs and a couple switches, and glue these connectors in so they can't move around. But anyhow, I have to build the protective circuit before I can do that. But this is pretty much the finished case. I got the LED strip running all the way around it. Whole thing's been 3D printed, and well, except for the little feet on the bottom. But I think that turned out okay. It's kind of rough on the top because of the blue painter's tape, but oh well, that's all right, because this inverter is actually going to sit about like that on there anyway. So anyhow, you could definitely just buy a plastic case to put this in, and it would probably turn out even better than this because it wouldn't warp. Or if you do 3D print a case, I'd highly recommend printing it in PLA. But you could just buy a normal plastic project box and cut the holes in it, drill these holes and cut the XT60 and the balance plug leads out of there, and that would work just fine. You don't have to 3D print it. This is just cheaper, and I have the materials on hand. This is the little protective circuit that I came up with. It's based around an AT1085 microcontroller, and this will have a high and low voltage shutoff, and should be able to carry quite a bit of current actually through that MOSFET.